Ladies and gentlemen, welcome to the meeting today. It's a pleasure for me to be here and been invited from PAGEV. I will now have a very specific, close look on upcycling and recycling with twin screw extruders, which is something specific, but maybe also something specific which shows you industry is working on things already, as mentioned by Mr. Riva earlier. The topic in upcycling and recycling are mainly challenges which I will have a first introduction. I will talk about the circular economy from Coperion view. Then I will talk about the challenges for the handling of the recyclates. I will show two examples of recycling applications Coperion and their customers are already working in. There are several, but two I will have a short look, and at the end I will give a short summary. Coperion is a leading manufacturer in polymer processing in compounding business, where we start from the material handling, from the silos, from the feeding to the compounder. And compounding machines is our core business, but also then the pelletizing and the material handling downstream. The two blue areas, I will have a closer look, what that means to recycling and what Coperion is doing in these areas. I would like to start with the picture of circular economy in plastics industry from Coperion view. It starts from the monomer in the refinery, then the refinery is doing the virgin polymers, and then the first step where Coperion comes in with the twin screw extruders is the pelletizing of the bulk materials like polyolefins, like polypropylenes, where we have lines running in the range of 50 to 100 tons per hour. As usually, these virgin polymers continue. They are compounded for special applications. That's also the topic or the problem in the recycling, that there's a various of final products out and not uniform single material which can be easily recycled. It's always a big mixture. Here we are doing a second compounding step, and that's also a core business Coperion have always been in. The new business we are looking in the circular economy loop is then using this technology for doing mechanical recycling. That means selecting or collecting the materials, regrind them, and making high-quality compounds out of it for reuse for new parts. Or we are also now already started with chemical recycling. That means the twin screw extruders are used to feed a reactor to go back from the waste to the oil. Also, we are working on solvent-based recycling for special applications. Here you get a rough overview how it looks like, or at least to get some ideas. And these are different flakes, recycled material collected in different ways, fibers, post-consumer waste, shredded bottles, and all that has then to be covered with storing, raw material conveying. It has to be fed to the compounding unit. We have to do high-quality compounding, filtration, sometimes drying afterwards, and also deodorization to have at the end a high-quality pellet which then can be reused for the application. The challenges in this area are storing and homogenization. I will not talk about that. The conveying and drying, I will also not talk about that. But the dosing and the feed intake and in the compounding line with these recyclates, I will have a closer look. So we have different recyclates like carbon fibers, film flakes. We have polyamide fibers. We have post-consumer waste. And all these different materials, we have regrind material from collected bottles. They have the challenge for making a high quality compound out of that is that they have irregular shape. Then very often we have low bulk densities, which is a disadvantage for effective compounding. We have different particle size. Very often they pass a washing process, so we have moisture where we have to deal with. And also it's a mixture of everything, so you have no specific product quality that also has to be taken in consideration. So therefore, special equipment and measures needs to be used to handle these recycling materials. One topic, for example, is the homogenization of free-flowing regrinds. That can be done by silos with a fluid coin blender or silos with mixing screws. And the other key topic is also that these materials are not free-flowing, so they are difficult to handle. They tend to bridge, so special silo design, special discharge agitators have to be designed and developed. So you see here, this is the complete process change from silo to via compounding to the final product silo. And there are two challenges where we have a closer look now. One is the feeding of the recyclates. As I mentioned, the low bulk density and the different properties. Therefore, Coperion, as a machine manufacturer, together with the sister company Coperion, has developed a special feeding system which allows us to feed this post-consumer waste, fiber waste, or carbon fiber waste on a belt feeder. So we have a gravimetric feeding unit, so we know each kilogram per hour which is fed to the extruder. And this allows us now to make a high compounding step afterwards to make a high quality compound. The second area where we also have done developments is the problem with the low bulk density of the material. So we have to develop a special feed intake unit, which then is used in the compounder to do this high quality. On this diagram, this is an example of a standard compounding machine, ZSK 58, which is usually for compounding processes running 1.5 tons, 1 to 1.5 tons per hour. If you look on the graph and look on the standard technology which was existing, these materials with low bulk density, we are able below 100 kg per hour to compound material, and that's not effective and nobody will do that. So a special development was done. This is this so-called mega feed device. And with this mega feed device, we are now able to feed this in reasonable throughputs rate comparable to standard compounding process. So that video shows you now both piece of equipment. So the ZSK mega feed, which are using the different recyclates. And also you will see the feeding device on the belt feeder where we know exactly the amount of material which goes into the line. Again, this is the area we are looking in. This is a typical compounder. And this is the so-called mega feed side feeder, which is developed to handle these special products. And this is the belt feeding system, also specially developed to handle this specific recyclates. Yeah. So you see this is a unit which is continuously feed the material on a belt. On that belt we weigh the amount, and depending on the variation in the product, the belt speed is adjusted, so we exactly know how much material goes into the compounding machine. Here this shows you this kind of compact situation. So if we increase the speed, we really see that a lot of material can catched from that unit and feed to the compounding process. And that was a big step forward using the twin screw compounder for handling this recyclate. Now I will have a look on two recycling applications which are already running at different customers. I will have a look on this multi-layer recycling and in the chemical recycling. Other technologies like PET recycling, which is also already state-of-the-art, bottle-to-bottle recycling or solvent-based recycling, and mechanical recycling I will not talk about. For the multi-film layer recycling, packaging materials are not that simple. They consist of several layers for barrier films, then with different functions. And the problem for these multi-layer films is that, for example, the polyolefins and the polyamides don't like each other. So if you just compound them, you will not get a good quality product. So using special technology, using high sophisticated compounding processes, we are able to make from the production scrap, in this case, a high quality pellet product. And that pellet product could be added into one layer of the multi-layer recycling film. Our customer is now running close to 50% of this regrind in the PE layer. Without that technology, just 5% could be used. So that also gives a positive impact on their energy consumption, on their cost, and also on their footprint. The other area, chemical recycling, that was also mentioned, that for post-consumer waste, where you have a big mixture of everything, it's difficult to do some specific recycling to get a good product. Here we are working together with the polymerization people because the reactor technology and the distillation, it's not our business. But here we are able to use our twin screw compounder to feed the reactor continuously with a high throughput. And again here the feeding device and the gravimetric feeder shown before is used for. And after the distillation, then it can go to the cracker and you can reuse that waste stream for polymerization of new products. A short summary, Coperion uses his strengths and competences over the years created, now looking also closer in recycling technologies. As Mr. Riva mentioned, we have to improve our technology. So new developments needs to be developed or needs to be done. And therefore also Coperion decided to build their own test facility for this material handlings, for these dosing and compounding issues, and to improve and to offer new technologies as well as new processes. And our Recycling Innovation Center will start in 2023 offering these possibilities for customers. Thank you for your attention.